Hello, this tutorial will introduce some simple and basic functions to better explore and understand data. We will still use the used car dataset from last tutorial, and we will also use read.csv function to import this dataset to the R. Remember to add the strings as factors equals to false parameter, so R will not convert every character variables to factors directly. So let's run this one and import the data to the R. Well, the first thing we usually do after we import the dataset is to get the structure of this dataset. So we'll use structure function here. So we can see from here, we have in total 150 observations, 150 used cars, and 6 variables describing those used cars. So we have three variables of integer type and 3 of them of character types. Well, besides using structure function, we can also use nRow and nColumn function to just extract the number of rows and number of columns of this dataset, and we can assign those numbers to a variable to store for later calculation. So here, number of rows I give it to the row variable, and number of columns I give it to the column variable, and you can output the value stored inside these 2 variables, which are 150 and 6. Next, we will also use the summary function to get a better understanding of the dataset. While summary function will output some basic statistic analysis results for the numeric variables. For example, now we have 3 numeric variables: year, price, and mileage. So summary will output the minimum, first quantile, median, mean, third quantile, maximum values of each numeric variable. And next is the mean function. You can only calculate the mean of certain variables. So here I will calculate the mean of the price of the used car. One thing to note is that when you want to retrieve, extract, and manipulate certain variables, the way to retrieve it is using the dataset name plus a $sign and together with the variable name. So it will only extract that variable column to analysis. Well, the next is median. Median function will output the number that in the halfway in the dataset. So for example, now I have 3 numbers. I want to output the median number among the 3. So it should be the second one being output. And next are the minimum and maximum functions. So minimum and maximum, you can just directly use minimum or maximum function, or you can use the range function. Range function will output both minimum and maximum right here. Well, the next is difference function. Difference function is to calculate the difference inside of this function. So if we include the range function inside this difference function, it will calculate the maximum price of the used car minus the minimum price of the used car. So these 2 lines of our commands are equivalent. And next, we will introduce the quantile function. If we only include the variable name and without changing any default parameter values, the quantile function will divide the whole dataset into 4 sections with equally numbered cases. So it will present you with the minimum value, the maximum value, and the median, and the 25th percentile value and the 75th percentile value. So this is called the first quantile, and this is called the third quantile. And next, if I only want to know the first percentile and the 99th percentile, I can change the props parameter and only present these two percentiles. And also, besides dividing this data sets into 4 sections, I can also divide them equally into 5 by changing the sequence parameter. So I can now show you like the 20th percentile, 40th, and so on. Well, next we will introduce 2 more plots to better analysis and visualize the numeric variables. The first one is box plot. Box plot will visualize the median, quantile values, and so on. So inside this box plot function, the first variable is the variable name, and you can add the mean title to this plot, and you can also add x-axis or y-axis title to the plot. So let's see what it looks like. So it does present as like a box right here. So this box, the lower line of this box is the first quantile value, and the upper line is the third quantile value, and this bold in the borderline in the middle is the median value. So what are those dots and this line and this line? So I will introduce you a value called IQR. IQR is the third quantile value minus first quantile value. So they will also calculate the maximum line, which is the third quantile value plus 1.5 times 1QR, and the minimum line is first quantile value minus 1.5 times IQR value. So if this variable has any values that is larger than the maximum line, it will represent them as these dots. It means they are outliers. And if there are any values less than the minimum line, it will also present them as dots. But right here, we don't have any dots down here, which means the minimum value is larger than this minimum line. So this lines represent the minimum value of the mileage, and this line should be the maximum line, and those dots are the values larger than the maximum lines, are the outliers. Hope you understand what I'm saying. The next graph is histogram. Similarly, the first parameter is also the variable name. So let's run this first histogram. So you can see that the x-axis is the mileage, and they divided them into 8 divisions. So this region of mileage has the highest frequency, and this histogram is used to check the skewness and the distribution of the numeric variables. So here, this distribution is a little right skewed. So right skew means we have a longer tail on the right than on the left, and also the mean is larger than the median value. Well, the last 2 functions for numeric variables are variance function and standard deviation function. So let us run this too. So standard deviation should be the square root of variance. So we will introduce some function to explore the factor variables. So we can retrieve, if we want to see like how many levels of the used car models, we can first retrieve this variable by calling its name. it will retrieve like 150 values, and it looks like they have 2 or 3 levels. Well, I will use this factor function to see actually how many levels this model has. So it will represent at the end they have 3 levels: SE, SEL, and SES. We noted that we have 3 character variables, right? So we want to convert those 3 character variables to factors. So for each of them, we can see like the level of them. So, well, we will use this factor function again and assign this factor back to this variable name. So note here we have the same name. So the factor variable will replace the original character variable. So let's run this 3. And remember, we used to have 3 variables that are character type. So now let's see the structure again. So see here, those 3 model, color, and transmission are changed to factor type, and they also list the levels, number of levels. Here it says 3 levels, 9 levels, and 2 levels. And next, we want to know like how many of each color or model are there. So we'll use the table function. For example, if I use, and we include the variable name inside this table function. So let's run this too. So we can see that, okay, so 35 of cards are in black, and 32 are in silver, and 25 are red. So most of the cards are model SE. Function called bar plot, which will visualize the levels of each factor variable. And I will demonstrate here too. So noted here, the first parameter is no longer just the variable name. You should use the table function to convert this variable into a table first, and then use this bar plot. So let's run this thing. So you can see that it looks still too narrow. It looks a little like the histogram plot, but it's different because histogram, the x-axis are numeric variables, but this one, the x-axis represent each level of the color. And yeah, visually they have spaces between each column, and you can visually see that the most of cards are in black, silver, red. And then lower frequency is blue, green, and white. Next, we will use the prop.table function to compute the table proportions. Well, when we use the table function, we get the exact number of the frequencies for each level. But if we want to get a percentage, the proportion of the levels, we can use prop.table. And let's run these 2 lines and see here. So SE model will take up like 52% of all the used car models. And remember to note it here. So inside this prop.table, there is a model table. Model table is already a table, so you need to use when you use the prop.table function, you need to like convert your variable to a table first, and then outside this table use a prop.table function. Well, next is how can we round the percentage of the proportions. We will use the round function and just telling R like how many digit place we want. For example, here we want 2. So let's see how it looks. So we times 100. So it is now a percentage. So here we see like black is 23.33%. and silver is 21.33. Don't forget that if you have any question or any concerns about the format or parameters of each function, you can always go to Help Windows by typing the question mark and the function name. So for example, here you have the question about rounding a number, or you have a question about the proportion table. In the end, we will talk about how to explore the relationships between two or more variables. We will first introduce some functions to retrieve the relations between two numeric variables. The first function we want to introduce is plot. It will visualize the two variables relationship. So we have, in this data set, we have three numeric variables. So we will use mileage and price to visualize their relationship first. And noted that we want x-axis to be mileage and the y-axis to be price. So let's run this function. So okay, so you can see from this plot that the cars with less mileage will get a higher price, and with higher mileage will get a lower price. So it looks like this two has a negatively linear relationship. And we can also use the correlation matrix function to compute their correlation. So we'll use correlation and include these two variables. And let's run this. So definitely these two has a very strong negative correlations. Well, besides using their variable names, we can also use their index numbers. So the price is in the third column and the mileage in the fourth column. So we can use column 4 to represent these two variables. And the last one is how we can use the table function to retrieve the relation between two factor variables. So we will include model and color variables inside this table function. And it will show us, okay, how many cars are in red, and also the model SEL, so they have like 2 cars, right? Well, these are the frequency like satisfying like both conditions. We can also use a proportion table to demonstrate the percentage. So here we use the prop.table. So it will show us the percentage. Okay, so that's basically what we'll cover in this tutorial. Thank you for listening and thank you for your time.